All right, in this problem, it's going to be number 30 from chapter 6. I'm going to be focusing on letter C, not A and B. C is where it becomes a little bit tricky. You have to actually take the difference in two energies to figure out the answer to it. So in C, it tells us that we're actually shining 439 nanometer light at some metal. And it's asking for what the energy released from this process is. And to be able to figure that out, you're actually going to have to translate these nanometers into, you have to translate it into energy. So to do that, remember, if we're going to get it into energy, energy is E equals h nu. This is wavelength, so we're going to have to use the equation. Oops, let me write it. Wavelength, or frequency times wavelength equals the speed of light. But don't forget the speed of light is always 3 times 10 to the 8th meters per second. So because of that, this has to be changed into meters. So let me change it into meters. 1 times 10 to the negative 9th meters for every nanometer. Nanometers cancel out. So I end up with 439 times 10 to the negative 9th meters. Just 439 times 1, folks. You don't need to do this in your calculator. So you obviously rearrange this equation to figure out what the frequency is. So its frequency equals the speed of light divided by the wavelength. So the speed of light, 3 times 10 to the 8th meters per second, divided by my wavelength in meters. And after I do that, I end up with 6.83 times 10 to the 14th inverse seconds. So now that I have my frequency here, I can plug that in here. So E equals H, which is Planck's constant, which will be given to you in all your tests, 6.626 times 10 to the negative 34th joules seconds times 6.83 times 10 to the 14th inverse seconds. When you do that, seconds go away, obviously, and you're left with your energy per photon that you're shining at this thing. And the energy per photon that you're shining at it is let me make sure I type this in correctly so I get the answer correct. So I take my calculator here, 6.626 E negative 34 times 6.83 E14. Hit that in, you end up with 4.53 times 10 to the negative 19th joules per photon. Well, now you have to combine this information with question A. See, this right here is the energy shined at the metal. Now, that's not necessarily all the energy the metal needs to actually emit some electrons. What the metal needs to emit some electrons is actually it's from A. It's the given information in the original question, which is 4.41 times 10 to the negative 19 joules. So wait a second. If that's what's shined at the metal, and this is what's needed for electrons to be ejected, there's a difference between these two. So let's take the difference. We can see what energy we have left over. 4.53 times 10 to the negative 19th joules. Subtract that from 4.41 times 10 to the negative 19th joules, and you end up with 1.1 times 10 to the negative 20th joules. And that's your answer for C. D is not required. If you want me to go over D, please come to tutoring on a Tuesday after school. Thank you.